Hello and welcome to Python, Beginners Python and Machine Learning. My name's Tim Cummings. Every week we work on a subject of Python. I'll be looking at collections today, which are ways of grouping lots of data. On the first week of the month, we do a session for absolute beginners, but we are still, every week of the month, we're focused on beginners. So feel free to ask questions. I'll be watching the Slack channel. And so there's a Slack channel. Peter's on, so that's good. He said hello. So you can ask any questions on that, or you can also ask questions on YouTube chat. And I'll try to monitor that, but sometimes they don't come through. All right. Today we're going to use Google Colab for running Python. This means you don't need to have Python installed on your computer. All you need is the Google account and a internet connection, which you obviously must have. So there'll be below the video, you'll see a link here to Google Colab, colab.research.google.com, and I've got a particular notebook that I've set up there. So if you click on that link, it will fire up Google Colab for you and open up the notebook. Now you'll see a read-only version of this notebook. That's so you won't be able to make any changes to that. So I'd suggest you click on this link here, copy to drive, and then you'll be able to make changes yourself, and this will help you to run any of the exercises that we're doing tonight. So click on copy to drive. You'll see the name is currently Meetup129 Tim Collections, and then when we've got a copy, it'll have the word copy in the name, copy of Meetup129 Tim Collections. Now I'm going to be typing into this one, so the one that I've copied, I will give you a link to that as well, and that way you can get any of the changes that I've typed just by refreshing this link. So I'll paste that in Slack and on YouTube chat. All right, so definitely ask me questions if anything that I'll assume that you know things if I don't ask questions. If you don't ask questions, so yeah, that's the only way I'll know if you need any help with anything. So Google Colab is a great environment for practicing Python. It's an interactive Python, so that anything you type in, you can get immediate results. It's divided up into these cells. You can see here's a cell's got a rectangle around it. This one's a text cell. This one here is a coding cell, and so you can see it looks slightly different. I'm going to start. I'm going to click on connect here. That'll get Google connecting up and creating a computer for us to work on, but even if you don't click on connect, it'll do it automatically when we get working. Alright, so what we're going to look at today, we're going to be looking at collections. So you're probably familiar with collections like list, tuple, dict, and maybe even set, and they're ones we've covered quite a few times before. But Python also comes with a standard library of other collections, defaultdict, namedtuple, deque, chain map, and counter. So they're the ones we'll probably spend a bit more time. But first of all, we'll recap on the four standard built-in collections. So I've called them L, T, D, and S here. I've got some variables. So L, you can see it's a list because it's created with square brackets, and each of the elements in the square brackets is separated by a comma. So I'll put in a couple of different data types here. I'll put in an integer, a floating point, and a string. Tuple's pretty similar, but you can see it's surrounded by parentheses, and I've put in some data types there. I've even put in a complex number, so it's a little fun little thing that Python can do. 3 plus 5j, so j is the square root of -1. If you don't understand complex numbers, don't worry, that's pretty irrelevant to collections, but just showing you that all sorts of data types can be used in collections. Now a dictionary, which is you can see by having the curly braces around it, that's made up by key value pairs. So the commas, between each comma you'll see two values. You'll have a key and a value that is linked to it, and between them you've got the colon. So that's how you identify a dictionary. And finally, a set also uses the curly braces, but this time it doesn't have the colons, so it's just single values between each of the value commas, and that's a set. Alright, now to run this cell we can click on the run here, which is the little play button, or you can see it's saying Control Enter is the keyboard shortcut. So Control Enter, I'll try that. Let's see, ran it, and we've got a tick. Happened very quickly for me, but you don't see any results coming out of that, and that's because of all the data there we've just stored in variables. We haven't told it to do anything with it. So let's have a look at the next cell. You can see when I'm down here that number 1, I can't point to it because as soon as I point to it, it disappears, but that says that was the first cell that we've run in this Google Colab notebook. Alright, lists and tuples, so that's an ordered sequence of values. So these things I can do them with lists or tuples. So we can use a for loop, and you can iterate over the values in your list or tuple, and each time it goes through the through the loop, it puts a different value in our variable v, and we're just going to print that value. So let's run this, and you can see the first time through the loop it printed the number 2, which was our first member of our tuple, then 4.0, which is our floating point number, then 6, and then our complex number 3 plus 5j. Alright, this should be pretty straightforward. So for loops require something that you can iterate over, and list and tuples make great sequences for that. Okay, so you can refer to the individual elements in a sequence by using indexes, and the index is put in square brackets both for tuples and lists. So 0 is the first element in the list, and 1 is the next 1, 2, 3. You can also put in a negative index, and that'll start back from the end. So this is a recap. I'm really just racing over this stuff. So the first element in our tuple T is the number 2, the last element. So last element -1 in our list L is the string 5. And I've just used an F string with formats in there to print them out. Once again, if you've got any questions even about how a print statement works, I can go over this, but I think most of the people watching have seen this already, and that's why I'm going over it, but it really is designed for beginners, so feel free to ask questions. Okay, within the square brackets we can also do slicing. So here you can see we just put a single number in the square brackets, and that referred to a single element in the list. Here we do put in a colon to say we're doing a slice, and it goes from 1 to 3. So that'll be index 1, index 2, up to, but not including index 3. And the reason they do up to but not including is so you can, if you subtract that value from this, subtract the first value from the second value, you get the number 2, and that'll tell you how many elements you're going to get, which is 2 from our slice. Slices can also be a bit more complicated. You can go starting at 0 up to a final value, and put in a step value as well. So that'll take every second value starting from 0 going up to but not including 3. And that's how we get those answers. Alright, you might remember things that we can do with lists and tuples. We can concatenate them, which means join them together. We can even multiply them. And so I put down a few examples here. So you can add lists to lists, and you can add tuples to tuples. You just can't add lists to tuples. Alright, so let's have a look at the first one, L2. It's got 1, 3, 5, and then, which comes from L, and then it's got 5, 3, 1. And what I've done there, I've just used the slicing ability of lists, but by putting in colon without numbers in there, it defaults to the first and the last, and then -1 is the stepping order I want to go through. So it actually goes through in reverse. So that's a neat little way to reverse your list around. So we've got the reverse of the list added onto the forward of the list. Okay, L3 is just L times 3, and you see 135, 135, 135. So it's just like we've added that list to itself 3 times and stored the result into variable L3. T2, once again, same thing, we're using a reverse of the list, 2, 4, 6, 3 plus 5j, 3 plus 5g, 6, 4, 2, and times 3. So yeah, we can see lists and tuples both work with concatenation and multiplication. Alright, if you want to convert between a list and a tuple, just like converting many data types in Python, you use the function which is the data type name with parentheses, and so if we put t in calling this function list, it'll construct a list based on the tuple. And so you can see L4 is a list because it's got square brackets around it, and T4 is a tuple based on our original list, and it's got the parentheses around it. Alright, so they're all pretty much standard things to do with lists and tuples. Now here's a couple of things you may not, if you're a beginner, you may not have come across it. What happens if you take your list L, which has got 3 elements in it, and you assign it to variables A, B and C, and you put them all on the same line. So let's have a look what happens when we type that in. And what that does is that unpacks all the values of a list, and we could have used a tuple there. It unpacks it into the 3 values and assigns them in order on the left. So we could have said A equals L0, B equals L1, C equals L2, but instead we've put it all on one line and not had to worry about indices, and so we've just said ABC equals L. Similarly, you can do it the other way around. So that's unpacking. Here's an example of packing. So if we have 2 values on the right hand side but only 1 on the left, then it will pack the 2 values into a tuple, never a list, always a tuple, and assign it to the single variable on the left hand side. So you can see T2 equals 5 and 1, and you can see that the type of it is a tuple. It will always be a tuple. Okay, so we can also do packing and unpacking when we're defining functions. So if we define a function, and remember in a function you use def to define a function, you give it a function name f, and then in the parentheses you put a list of arguments that you want to take the values that are passed into the function. Now sometimes you don't know how many arguments are going to be passed in, and so you don't know how many names to put in there. So what you could do is you create what are called positional arguments, and it'll just take as many arguments are put in, and then the asterisk here that says pack them all up into a tuple. So I've used the name arguments there, args. That is a convention that a lot of Python programmers will use in this scenario, but you really can call it anything you like. But what's doing the work here is this asterisk, and what the asterisk is saying is, regardless of how many arguments are provided, just pack them all up into a tuple, and then this function can use them like a tuple. So we've defined this function here, we've called it. So let's run this and see what we get. So it says args equals 975, and the type of it is a tuple. So it's done exactly the same thing as the packing that we did here. T2 equals C, A. It's just packed it into a tuple with type tuple, and that's that single asterisk. Alright, so what are the difference between lists and tuples? Tuples are immutable and lists are mutable. That means that when they're tuples and lists, they each are in their own bit of memory. If you want to change a list, you can change it within that bit of memory that it exists. If you want to change a tuple, you can't. You can create a new tuple in a new piece of memory, but you can't change a tuple in this existing piece of memory. And that's quite a good thing. If you can use tuples rather than lists, you'll find that you'll avoid some quite obscure programming bugs that can creep into your code. So I'd recommend try to use tuples whenever you can, but if you absolutely need that mutability feature of lists, then use lists. Okay, let's have a look at what we can do with lists. Lists can have values added or removed. So let's create a couple of lists here, L5 and L6. That's just to work with. So L5 index 7, we can set it to a value 0.7. So that's a way of assigning a value to an existing list. So let's just run this so that we can see what the data is that we're dealing with. So here's our initial L5, and then we run L5 index 7 equals 0.7, and you can see the value with index 7 has now been changed to 0.7, right when it was 3.0. So that's changed the list in place. It's still in exactly the same place in memory. All right, then we did a remove 1, and you can see the value 1 got removed. Remove only takes the first time it meets that value. So we did remove 1 again, it will then remove this one. Alright, this time we're using the Python keyword del. You can see it's in a purple color. Delete L5 index 4, and it's taken the string 5 out of the list while it is there in place and left everything else there. Okay, L5.extend t. It's taken our list and added in a whole bunch of values from another tuple. Append 100, it's appended one value. So you can see the difference here between append and extend. Append adds one value to the end of the list. Extend extends the current list by all the values in the whatever the sequence is that have been extended by. So that could be if there were 4 elements in that tuple, it would be extended by 4 elements. If I did append t, it would only be extended by 1 element, and that 1 element would be a complete tuple. Alright, some things here. Pop is a method you can run on a list to take the last value off the list. So when you run pop, it takes it off the list, but it returns it, so you can then assign it into a variable. So we can put it into the value p, and we say after pop, then p was equal to 100, and L5 is all of that without the 100 on the end. So you can see that's been popped off. You can also pop from the front with pop 0, and you can see it's returned the value 3 and taken out the verse value. Now the reason I'm talking about pop here is it'll come in useful when we're looking at decs later on. Okay, list has got a sort method. We can sort them. What are we sorting? L6. So L6 is these ones, 5, 3, 7, 2, 8. And after we've sorted it, L6 has been sorted in place to 2, 3, 5, 7, 8. We can insert at index 4 100. We can even set a slice to a bunch of values there, which is interesting. You know, I've taken a slice which had 2 values in it, and I've replaced it with 3 values. So the 3 and the 5 have gone, and in its place have gone 21, 22, 23. All right, we're just racing through these at the moment, so you can see the sorts of things that you can do with lists and lists. Yep. Okay, so task 1, achieve similar results with tuples for some of the above operations. Alright, so let's try this first one. L5, so let's see, we'll set up some values. So you can work through this exercise yourself if you think you want to have a go at it. So this will work on exactly the same thing, but I'm going to convert it to a tuple, and T6 is going to be a tuple. Alright, now the first thing I want to do is assign the 7th value to 0.7. So let's have a look at what T5 is. So you can see it's a tuple, and this value here will be index 7. Let's add in a couple more code cells. I can do that by clicking on code here. Alright, now if I try referring to it by the index and putting that on the left side of an assignment, which is the equals operator, and try running that, you'll see I'll get an error. Tuple object is not a support item assignment, and that's because it's immutable. So if I wanted to achieve that, the way I'd have to do that is have to create a new tuple based on the old tuple. So I'll call it T7 for now. So it's going to be everything up to 7 plus the value 0.7 so I'm going to create a tuple with that in it. And to do a single value tuple, I have to do a comma, otherwise it thinks the parentheses are the mathematical parentheses. And then I'm going to get the rest of our original tuple, but without the original index 7. So we'll go from 8 onwards. So let's have a look at what's in T7. So everything's the same, 135, 135, 1, and 0.7 and 5. Okay, any questions about that? So it was more work to do it. It stored it in a new location. If I wanted to store it in T5, I can do it with T5. I can say T5 equals, and if we look in the solution, that's in fact what we did. T5 equals. So if you look at all these solutions, every one of them is T5 equals, T5 equals, T5 equals, T5 equals. And what that means is we're setting up a new tuple. We can't change the existing tuple in place. If we want to achieve that same functionality we did with lists, we have to actually create a new tuple, and then we can write it into it'll go into a new memory location. We can give that new memory location the same name that we had for the old one, and when there's nothing in your programs referring to that old memory location, then Python will go in and clean it up and just free up that memory for you. Alright, so I won't spend too much time on these existing tuples and lists. Okay, why would we want to use tuples? They're just harder to use. Okay, here's some more reasons to use them. Tuples can be hashable, so the keys can be keys in a dictionary. Lists are never hashable because they are mutable. Immutable reduces the possibility of programming logic errors, which is what I said before. And there can also be memory optimizations when using immutables, but not if you're using... okay, so if you're having to do these workarounds, then you're pretty much cancelling any memory optimizations that you're going to get from using tuples. But if you're not having to do these sorts of workarounds, then yeah, the Python compiler can actually optimize some of the memory for you. Alright, so here's an example of using tuples to sort coordinates in a sparse matrix. So we're going to create a dictionary here. Our matrix is going to be a 7 by 7 matrix, and we're going to use tuples for our key, and these are basically coordinates. Now I've written a function to display this sparse dictionary, just because we're going to call it a few times. And so let's have we'll run this bit of code here, and we'll call it display sparse to see what went in the dictionary. And you can see that's what's gone into the dictionary. We've put single slashes at I 00112233445566, and then on the other diagonal we've then put these ones in. So that's at 0 so n minus I minus 1 0 6 1 5 2 4 3 3, so that's overwritten the slash from the previous 3 3 and so on down there. Alright, task 2, put a vertical line of pipes for x equals 1. Okay, so I want to say for I in range n, so I want to loop through this n times, and each time for value n I'm going to set the dictionary using the index, and my coordinates are always going to have x equals 1. So let's go 1 for my x coordinate, and my y value is going to be every value of I. So let's try I there, and we're going to set it to a vertical pipe, which you can either copy and paste that, or it's on your keyboard, on my keyboard, just above the enter key, shift with a shift. Okay, and let's display that to see what it looks like. Okay, so you can see what's happened because we're using these tuples as our keys in our dictionary. If the tuples match, so in this place 1 1, then it will overwrite what was previously there and puts in the new value. Okay, here's a solution. So the solution is doing the same thing. It's using dictionary comprehension to create a new dictionary of just the vertical pipes, and then it's calling the update method on our original dictionary to just take all those values and updating them into our original dictionary and then displaying it. And so we'll just check that. That gives the same answer, although I should really run this again to reset our original dictionary, and then run it again, this one, to make sure we weren't just getting the answer from here. And so that worked. Alright, now do people understand this dictionary comprehension? And do they understand what the update is meaning? Okay, dict is a collection of key value pairs. We've been through this. It must be hashable, so your keys can be int, string, tuple of. And when it's a tuple, it has to be a tuple of hashable values. Like you can't have a tuple of some other values that are mutable, for example. Every value in the tuple has to be hashable. So dict is mutable, so it can't be used as a key for another dictionary. All right. Now our dictionaries, since Python 3.6, they're ordered, which means that the order that you create the keys and values in the dictionary is the order they will always return. And so this takes out the requirement for one of our collections in the collections standard library, which is ordered dictionary, because now all dictionaries are ordered. All right, set. Set is a unique collection of values, is mutable, and it is unordered. So unlike dictionaries, it doesn't have an order. So when you're creating a set, so when you're creating a list, you can create a list just using square brackets. A set, is designated by curly braces, but if you're trying to create an empty set, you can't just use that, because as you know, Python thinks that that's an empty dictionary, not an empty set. So it would be ambiguous. So if you want to create an empty set, you have to use set, the set constructor. So here's an example used to find the x values for all the even y values in dictionary D, which was our x with a vertical line. All right, so we're going to go a loop through D. What that does, it takes the keys of our dictionary, and each time through the loop puts a different value of key into our loop variable, which is t. And we only want the tuples where y is even. So y is the second parameter. We can refer to the second parameter using index 1. And we can check if it's even by doing modulo 2, and which means take the remainder, find the remainder when you divide by 2. And if that comes to 0, then we know we've got an even number. Okay, so we're going to, if it's even, then we're going to append it to our list, and we're going to add it to our set. And that's going to see what the difference between our list and our set is after we've run this code. So you can see the list, it goes, oh yeah, there was, for a y was even, we've got 2 values of x, 2 values of x, another 2 values of x, and 4 values of x equals 1 for y values of for even y values. So they'll be your vertical pipelines, pipes. These will be your slanting ones. We had one on each. Okay, now the set of x took exactly those same values, but you can see it's only stored one of each of them, and that's because set creates a unique, just gives us a unique sequence, and so it's very useful if you're trying to find unique values. All right, find all the unique values in D. Okay, so we can do a loop through all the values in D, and we can get those values using this method on a dictionary, which gives us all the values. And maybe I should create, we'll say SV equals a set, and then we're going to add that value into the set, and then let's have a look at what it looks like at the end. And we can see we've got the forward slash, the backslash, and the pipe. And the reason there's 2 backslashes there is because a backslash is a special character in a Python string, so it has to be escaped. So if you printed that, it would print a single backslash, but if you are looking at the value in interactive Python, or you wanted to create it, you'd have to use a double backslash. All right. Similarly, solution 3 here uses set comprehension, so it does the same sort of thing. It doesn't have to use add because it just uses the comprehension to put all the values in there. So let's see if that worked. Gave us the same answer. All right, now to use a standard library in Python, we don't need to install anything. It already comes with Python. All we need to do is create an import statement to say that we want to import it. So the name of the standard library is collections. The name of the class that we're trying to import, in this case, is ordered dict. And we just say from that library import ordered dict. Or you could have just said import collections, in which case you would have to then call it collections.ordered dict every time you wanted to use it. This is how you create an ordered dictionary, and you can see that the class, the type of it, is collections.ordered dict. Nothing special about that. You can convert it to a normal dictionary using the dict constructor, and you can convert back a normal dictionary into an ordered dict using that constructor. So they work as well. All right, so let's grab some data to for the next set of examples. I'm going to go to this website here. So the Brisbane City Council has given us some open data to play with. We're going to look at ferry terminals. So if you go to this site, and if you want to find other things that they can do, just search on open data at Brisbane City Council. So here we go. This is Brisbane terminal locations as a CSV file is one of the options they've got. We're going to look for it as a JSON file. And if we look in here, data API, I'll click on that. And it brings up ways that we can, well, it brings up an API here, data store create. I don't think we're going to be allowed to create. You're going to need permissions to do that. But what we can do is look at this Python example down here, because we want to use it in Python. So if we look at this code, we go, great, we've got some Python code, let's copy and paste that. Now I'm just going to warn you that this is Python 2 code, and the most telling feature for that is the print statement. So in Python 2, print was a command, a keyword in Python, but in Python 3 it's just a function. So if you wanted to call it a function, you have to use parentheses with print, but they haven't used parentheses with print, which means they're using it like a command, and in that sense they must be using Python 2 to have done that. So we'll go back to our notebook where I've already copied and pasted this code. This is the code that they provided for us. I'm going to show you the Python 3 equivalent. So that's what a print statement should look like. A print function in Python 3, it needs those parentheses around it. Now the other thing that was different was URL lib is a bit different in Python 2 than Python 3. So what we want to do, URL open is in a different place. It's in this the request module of URL lib. So now it used to be just in URL lib. So we can import just that directly, import from URL lib.request, import URL open, and the rest of it is the same. Okay, so if we run this code, it's actually going to go from our Google Colab instance and call up the web location for the API at Brisbane City Council and get the results. And there's the results that came back, and it just tells you some information. It actually didn't tell you much. So that's I've just done that as a direct translation from Python 2 to Python 3. Now we do a little bit more with that. This is the other things that we can do. We can convert it to JSON, and I'm not going to go into JSON too much detail here, but if you want more details about JSON, look at our Meetup 74. We're going to load the results of this. We're going to limit it to 2. For some reason, the sample query they gave us was a query title as Jones, because none of the ferries titles are Jones, so that returned no results. And they put a limit of 5. So we're going to return all the results, except we're going to limit it to by 2, but we're not going to have any filtering query. So it's just going to give us the first 2. And it's going to store the results into a dictionary. So that's what json.load will do. It'll take this URL, get the data from it, and then return the results in a dictionary. And then we're going to use pretty print for the dictionary, which just looks a bit better than this, which is a bit hard to view. So we can see, and pretty print's another standard library of Python. So you can see this shows the dictionary. It's got it's got nested dictionaries to make fun. So help is our first key with a telling you where to go to get help. Results is the only other thing that's in there, and results is a nested dictionary. It's got some links, so if you're creating a web UI and you want it to page forward and back, it tells you what the URLs are for the next lot of 2, if you want to go 2 at a time. But this is what's more interesting, our fields. It tells us all the fields that are in this data set. It also then gives us some data. So we've got 2 records of data. So we've got one at 44 Ferry Street, and we've got one at 32 McCrossan Street. And you can see all the different things that we've got, whether there's drinking fountains present, a description, Eagle Street Pier, Ferry Terminal, latitude and longitude. So now we're going to do some exercises with this data to show some of the power of these collections. Alright, so now let's get all the data rather than limit equals 2. So you can see this time we did URL open, URL, and limit equals 2. So now we'll just do URL without the limit equals 2. So we'll get all the data. And then we'll pull out the records list from our results, which is nested into the outside dictionary, because that's really the only bit that we're going to be working with. Alright, let's have a look at that, and then we'll look at the first one. So there's 24 ferry terminals, and the first one is this one, Dockside Ferry Terminal at 44 Ferry Street. Alright, now we want to categorize by their pontoon material. So let's have a look. Pontoon material, this one's concrete. There's a few others in there. I'm not sure exactly what they're going to be. So how do we do this? So this is, think about how you'd go through that, and you want to return a new dictionary by material. So it's going to have, the field is going to be the material. So say concrete, and then we want a list of all the terminals that have concrete pontoons. So the way we do this, we'd loop through, we'll say T is our terminal, loop through all the terminals in terminal. We'll start off with an empty dictionary, dict by material, and we'll find out what the material is for this particular terminal. Then we'll see if we've already stored that in dict by material, and if we haven't, then we better create a new list of terminals that are going to have this material, and then we'll append this terminal's description to that field in our dictionary. So let's run that and see what it looks like. So it says we've got steel at QUT Gardens Point Ferry, Brett's Wharf, and UQ St Lucia. We've got steel with a space after it, Milton, Mowbray Park, Sydney Street, and we've got concrete at Dockside, Eagle Street, Apollo Road, and South Bank 3. All right, so that's one way of doing it. Now it turns out that this sort of code is fairly boilerplate code. People are having to do it quite a lot. So that's how they came up with the default dictionary. So what the default dictionary does is, rather than saying if you have to do a check, is material in the dict by material, does it exist? If not, create a new list. It'll do that automatically. So all we have to do is but the funny thing about this is we have to give it a parameter, and the parameter is a function name that will create our new default value in the dictionary. Now, fortunately for us, list, we can use the function name, which is list, because we could call list with list parentheses to create an empty list. And so anytime we Where are we? Here we go. List. Default dictionary list. Anytime we said dict by material for that pontoon material and it didn't exist, it will create an empty list and then it will append straight to it. So we've cut out a couple of lines of code. While we're at it, I also threw a strip in there to get rid of some of those spaces in the data, because the data obviously needs cleaning up a little bit. And so let's run it with this code. Does the same thing, and it just looks at, I mean, it really will be, if we put the strip in the original code, we'd have exactly the same results. But it's just a couple of lines of code quicker, and so a bit easier, less likely to make mistakes. Okay, so our task here, task 4, categorize the ferry terminals by the number of boarding gates. Okay, so if we look here, we can see in our fields there's a field called boarding gates. All right, and we'll just copy this code here because it's going to do very similar to what we're after. By gates. I think it's going to be a string, so we can run strip on that, and we'll append the description, and then we'll print it out. So we can see these are the ones with 1 boarding gate, these are the ones with 2 boarding gates, 3 and 4. So it's a good way of categorizing things, and the default dictionary really helps us to do that. So look at the solution. Okay, so the solution, I left my keys as strings, but in the solution we're converting them to integers, so you can see that that would work as well. So let's run that and see. You can see our keys here are integers, 1, 2, 3, 4. It works just as well. All right, anyway, so play around with default dictionary, see what some of the things you can do with that. All right, let's have a look at counter. That's also in the collections group. So we can import that. It's a class. You see, sometimes they're using uppercase or title case for class names, and sometimes they're just using all lowercase. You'll probably find the ones that are all lowercase have just been there since very early days of Python, before they settled on the convention of class names being title case. So what are we trying to do? We're trying to we're going to create a list of all the numbers of boarding gates in our list of terminal. So we'll just use list comprehension to do that. And then we're going to create a counter out of that list, and let's have a look at what that gives us. So it says, here's the counter. It says 3, which is the number of boarding gates, appeared on 8 of the terminals. 2 boarding gates appeared on 8 of the terminals. 1 boarding gate appeared on 7 of them, and 4 boarding gates appeared on 1 of them. So if you don't need to actually categorize them like we've done here, if all you need to do is a count of them, then a counter is a very quick way of creating that code. In fact, I could have put this list comprehension directly into the parameters structure here and done it all in one line. Most of this code is just presentation. All right, how many have drinking fountains? So let's we'll find a list of all the different values of fountains, and that's just going to be drinking fountain present. I think that might be the name. In list. So Google Colab's pretty good at guessing field names in our data. And then we just create a counter of that. So 19 of them there was no drinking fountain. One of them they didn't even specify whether there was or there wasn't, and 4 of them they've specified yes. So you can see that's pretty quick. And you can see in the solution they've even put I've even put the list comprehension directly into the constructor for counter. And looking up yes is 4. So that's how you can refer to a particular field within the counter. Alright, so now we're going to move on to named tuples. So named tuples, they're a cross between a class and a dictionary. They're a lightweight structure which can replace simple classes. It can be used where tuples can be used. And they also allow you to refer to the elements of a tuple by name rather than by just position. Because up until now we've only been able to refer to each element of a tuple by its position in the tuple. So we import named tuple from collections, and in named tuple we give it a class name, and we give it a list of parameters. So this can be the named keys, can be an iterable sequence of strings or a single string separated by space and or comma. So in this case we've used a single string and the values in there are separated by spaces and commas. So then I can create a point that creates a class that now creates an instance of that class, and I can print it. And let's have a look at what we've got. And you see we've very easily created a class. So when you've got a lightweight class, it doesn't need to do anything, just really store data, a bit of a data structure. You can use a named tuple for this situation. So we've set our tuple as having the values 1 and 2. So let's put that on the left-hand side of an equality condition, and we'll put on the right-hand side just a tuple with the values 1 and 2. So we'll see how our named tuple compares to a straight tuple, and they test for equality that returns true. All right. Now you know that you can refer to an element by its index. So like if I say P0, it should be number 1, that's the 0 index. But I can also refer to it now by name. So because we've given names x and y, I can now use p.x and it will return 1, and p.y will give me a 2. And if I print it out, I can see x equals 1, y equals 2. So it just makes the data a little bit easier to read. If you want to use the dictionary type nomenclature, so for example, I wanted to get the x value of my point, but x I wanted to be stored in a string, then I can't use the x in square brackets, but in that case you'd have to use the built-in Python function getAttribute, which is what you would normally use if you needed to do that. Same thing with a class. And you can see getAttribute of p, get the x attribute. So if this was in a string s, we could just put s in here, and if s, so I'll actually do that to make it clear. So let's say s equals y, and you see it gets the value 2. Now I couldn't do p.s because s is not an attribute of p. S is a string that contains the name of the attribute that I want. So that's why you use getAttribute. Now remember, in a dictionary I could easily have done, if P was a dictionary, I could have done that, PS. But I can't do that for a named tuple, but this is the workaround. If you need that functionality, use getAttribute. Now remember, we did our sparse dictionary before where we were using normal tuples. Now let's try to use our named tuples for our attribute, and we'll even do them in the same dictionary. How about that? So I'm going to use this. So for I in range n, I'm going to put the values in I, 1 and I, n minus 2, and in I, 1 and n minus 2, I. So I've used this notation, equals, 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 and then finally the value that I want to put in all of those values. I could have written that down as 4 different lines, but I just thought I'd show you a different way of doing things. And there it is. This is showing our sign, and you can see that's we've put in this character in all these locations. So what does our dictionary look like? So remember, before we created some that had a tuple as a key, and so that's stored in there. Now we created new ones, so you can see they've used our new name tuple as the key, but some of the existing ones we've overwritten existing text. This is why this is looking a bit weird. The characters are not all the same width. So these characters, if they were all the same width, they would show up over here. But my hash signs are a bit wider than my slashes. But anyway, getting back to this. So this key already existed, and now we've replaced the slash with a hash. So it hasn't changed the key, it's just left the original key that was there, because as far as it's concerned, they're both equal. It's only the new ones that it's created a new key. So you can see that the name tuples and tuples are totally interchangeable. All right, task 6, convert the list of terminals to a named tuple. Note that named tupled keys can't start with underscore, so we will rename that key. All right, so let's run that. So let's have a look at what is in T. So that'll be the last time it went through this, and we can see, yep, we've got ID is it now doesn't have an underscore to start with. I better explain what this does. So pop takes the value. We did it on lists before. Now you can do it on dictionaries. It takes the value with this key and pops it out of the dictionary, so that key no longer exists in the dictionary. Now we want to put it back in the dictionary, but with a different key, basically the same name without the underscore at the front. So that's what this assignment does. TID equals t.pop underscore ID. All right. So now if I look at all the keys in my last terminal, that gives me a list of all the keys. So I want to use them for my keys in my named tuple. So let's try to create a named tuple. So we're going to call it terminal. And then it wants a list of all the keys. We might find that won't work exactly as it is. Oh, that possibly did work. Yes, that worked. So, and then we want to create a terminal. So to do that, we need, but have a look at what's in T again. We need a key equals a value, key equals a value, key equals a value for our named tuple. We can't create a named tuple and then add each one of these individually. They all have to be added at the same time. So how are we going to do that? The way we can do that is we can unpack all of these values using the double asterisk symbol in Python. So let's do this. I'm going to create a list of named terminals, named tuples. So it's going to start off with an empty list. And now I'm going to append to my list a new terminal. And this is where I've got to put in all the values. So I've got to say like accessibility. Well, let's just copy this. Equals disabled access, so that's got to be a string. Alright, so I need to have all these values and an equal sign between each one. And then comma, adjacent property address equals 14 Gordon Street. Now that's going to be hard work to do all that, but I can use the Python unpacking tool, which is double asterisk, and that'll unpack a dictionary with a key and a value, and give it a name, and pass it through to this function or constructor as a keyword argument. Alright, and let's then just have a look at the first one. Okay, so here's our tuple. It's a terminal. It's got all these key value pairs. So that worked. And that's my code. If we look at the solution, it creates the named tuple, and it uses the unpacking, and we use list comprehension to create the list. So it's a little bit shorter than what I did, and then pretty prints the whole lot. Okay, let's see what that looks. Yep. So how are you going with this? You understanding what's going on? We're getting close to the end now. I'm just really touching on these of just the things that you can do, because you probably won't use them a lot. Definitely not like lists, tuples, dictionaries in your normal code, but just when you do want to use them, it's nice to know that they're there. Alright, let's quickly look at deque. Deque is a high-performance thread-safe double-ended queue which can act like a stack, which is last in, first out, or a queue, which is first in, first out, or even a tail, which is a fixed queue size. So I'm just going to show some examples of how to do this. I remember before we were popping off the end of the list and off the beginning of a list. With a deque, you can do that with much higher performance. So if you are going to be frequently popping something off the beginning of a list, then try using a deque instead. Alright, so Peter's saying brain went walkabout when you mentioned named tuples. Really just think of named tuples as dictionaries, but that you can't change, but they've got some of the features of classes. All right, so we're going to import deque from collections. Here's an example of using tail. So tail is a thing that you often do when you're you want to look at the last so many lines of a file. In Unix, you can just call tail on that, and if extra lines keep getting added to that file, the next time you call tail, you'll see only the new last 5 lines or so of that file. So we're going to create an example where we're going to keep appending a value to the end of a list, end of a deque actually, but the deque is designed with a maximum value of 5 in it. So every time we look at it, we're only going to see the last 5 values. So you can see as we were appending, we appended 0, then 2, then 4, then 6, then 8. And then when we appended 10, because the maximum length was 5, then we lost the 0 off the front. And we appended 12, and suddenly we lost the 2. So you can see that's an easy way of keeping a queue with only 5 values in the queue. And the deque keeps track of that automatically for you. So there's hardly any code there, but it's a functionality that would be quite hard to write reliably well. All right, a stack. So stack is called last in, first out. So when you can either append or pop on a stack. When you append, it adds it onto the end of the stack. When you pop, it pops off the end of the stack. So you always append and pop at the same end when you're using a stack. And stacks are useful. Well, it's used by Python when you're doing functions, function calls back, especially recursive functions. When you call a function, it puts that function onto the stack so it knows where to return to. And then every time you do a return, it takes the last value off the stack to know where to return back into your code. So you think about it, when you say return for a function, it remembers where it's come from and it just returns back to that spot, and it uses a stack for that. If you have too many calls to a function, you'll get what's called a stack overflow, and that's what happens when you have a recursive function that doesn't have a way of escaping out of it. Alright, so let's have a look at our example of a stack. So we start off with 0, 1, 2, 3, 4, and what are we doing? We're appending 5 values and then we're popping 2. So then 5 go on, 2 go off. Another 5 go on, and then 2 go off. Another 5 go on, and then 2 go off. So you can see our stack's growing and growing, and then if we just kept popping at the end, it would bring it back down to a 0 length stack. So once again, that might be useful in some code that you're trying to write if you need a stack. Here's a queue, which is first in, first out. So in this case, you append and pop at different ends. So you can see here we've appended and popped. Here you can append and pop left. Now there's also, I think it's called append left and pop if you wanted to append on the left-hand end and pop off the right-hand end. So let's have a run this example, see how it goes. We're doing the same thing, 5 and 2. So we add 5 and then we pop 2. And the pop 2, they get popped off the left-hand end. The appending appends onto the right-hand end. Popping 2 off the left-hand end, appending 5 onto the right-hand end. So you can see that's a queue that's working its way through. The people who've been in the queue the longest will be the first to get served. Alright, chain map is the last one we're going to look at tonight. What chain map does is it works exactly like dict update, but it doesn't alter the underlying dictionaries. So this is useful. Say you've got dictionaries in with some defaults that you want to be overridden. So for example, I'll create these 3 dictionaries. So D1's got ABC in it, D2's got CDE, D3's got DEF, and then we create a new chain map called CM. And let's just have a look at what CM looks like. So it's got D, E, F, C, D, E, A, B, C. So it's got all the underlying dictionaries are in the chain map. But if you, oh sorry, that's right. all the underlying dictionaries are in the chain map. But if you called out the keys for it, it's funny I didn't put any examples of calling out keys. So let's have a look at so if I want to see what chain map D is, it gives me 21. So it goes along till it finds the first value of D and then returns that. So even though there's a value of D here, it'll return this one. Similarly, if I look for C, it gives me 11. So it looks through here until it gets to C11 and then it returns that value. Now these underlying dictionaries, I could actually make changes to them, and the chain map would use the new values of the dictionary. Oh, and this is what I'm doing here. So I've converted the chain map to a dictionary, and then you've no longer got the duplicates. So you can see C is 11, just like we found here. C is 11, D is 21, E is 23, F is 25. So they've come from there. So that's consolidating them all. But the original chain map still exists. This has just created a new dictionary. Now, if you make a change in the chain map, it only affects the first dictionary. So this one here. So you can see this first dictionary has now got a G of 31 added. Similarly, if you change A to 33, even though A exists in other places, A will get added into in fact, this first one is the dictionary. This is the chain map. Well, it's the D3. I'm not actually printing out the chain map. So there's D3. That's the only one that got affected by putting a G in there. And if I add an A, set an A, it puts it into D3. It doesn't affect the A that's in D1 or D2. So once again, you may not have a lot of use for chain maps, but I can think of when you're setting up defaults and preferences and for a program, that's the sort of time that you'd want to use it, because you often want to have defaults and then be able to override them. All right, so any more questions there? That's all from me for this week. Next week we're going to have Arun is going to be doing a couple of weeks of machine learning, so that could be interesting. If you like the video, please click on like, and I'll be back in the first week of February with an absolute beginner session. Thank you.